everyone. Today we're just going to be doing some launching things. Let me share my screen real quick. We can show you all some stuff. Recently I just switched over to Chrome. It's an interesting thing. But yeah, let's start by sharing my screen. Oh, we gotta fix this real quick. Cool. Oh, oops. Let me just close this. Alright. Again, everyone. Let's go back. Okay, I'm sure I did this. Well, oh shoot. Okay, so you guys should be able to see my screen now. Hopefully. Um, yeah, so we can just do this. Okay. Next up, let's open up our CAD.launching.com. Just gonna be doing some stuff. Here we go. Perfect. So, in case anybody wants to chat, do this. Okay. Stop it real quick. Okay, today we're going to be working on um, some on-chip stuff. We're just going to be doing this. So, okay, right now, what we're doing is we're just going to setting it up. Boom, let me some content. Bye-bye. And just see robotics. I might try to get some videos up soon. Wait, I just let's see what's real quick. Sorry, that was a little bad. Next step after this, we're going to set up some more links. Okay, cool. I should move it and distribute elements. Yeah, let's keep like this. Except the body. These fit distance. Otherwise, we don't need to. Let's yes. That's here. That's here. That's one off. That's play. Of course, this is simplified, but you all know. Let's get the music playing, shall we? You know what? I love it. Yeah. Okay. over, but it rotated 15. Yeah, so like that. Okay, it's like acceptable. And you know it's a little bit. Yeah, there you go. Okay, so you see this bit, over here, and so you see here, it's called the drag out. Drag is good here, up the shaft, up these gears, and here about. And after this, um, we're going to power up the shaft here. Got a little pulley system over here, and then we got the pulleys down into here. I'm not going to give you wires. So next up is the thing. I want to offset this like 60, 60 damage. And that should align them together. Uh, in these flange bearings, see here, this little thing. This is three apart. Where is it? Right here. Factory. Uh, the entirety of it is 6-3 though. I'm not going to the very end. I can show you real quick. Okay, hold on. So over here, all the way over here is 0.063. See? So the reason why we're doing this is because I'm actually going to add another bearing. In case you were wondering if you're following along, these are 1.125 OD flange bearings for half inch shaft under hex. So I'm just gonna put this into here. I don't have to go too much. Actually, no, I don't want to do that. I want to do it the other way. So the reason I want to do it the other way is because give me 1 second. So the reason I did it this way is because you want to make sure that the shaft can't output itself through either way. So I have the bearings facing inward. Um, yeah, facing inward, they're outward. So see, they're on the outside here, and that is what's gonna let it have its. I don't really know what to say. Like it's not gonna slide. So after this, um, I'm gonna put a 16-inch spacer in between, just so that they can fit a little better. This tool, you can do Command C, Command V, or Control C, Control V. It depends on what you want. So here, I'm just gonna input it right here. And do that. Okay. good now. Yeah, now what I'm here, it's technically point eight eight, 4.8 and I don't want this. Yeah, point eight. So, we'll add it. This is a little bit problem with the sketches, and like how I made it work. You can see here, on this one, you can make a custom space here. Also, I do, I want this to be like right here. Yeah, this is fine. See here? Yeah, that's fine. And then, okay, perfect. So this is like, you see here that, when we made this here, I already made all this stuff. This is this one. So, this will be a good video. What I want to do is click this center to the center flip. And so that's the line now. Um, yes. Um, the thing is, I don't know. Yeah, there we go. That's where I'm so sorry. You gotta offset a little bit. Typically, I do like 0.05. Does it look point 1? Yes. Yeah, it's fine. Like 0.075 typically is the best number. You don't have to have it perfectly center. Well, just in general, so I think they're what 0.15 in distance. Let's see, 0.5. So I don't really know if the measurements are good to be honest, but okay, that works. So then in here, these are basically touching, but you have a tiny little spacer there. Actually, I should just delete this. See, this thing is in between these two, you could technically fit like a 32nd inch spacer. What's the actual distance? It is. Okay, I don't want to what's center distance. Like 0.021, which is way too small for anything to fit. So, that's really not going to work that well. But what you can do, oh, also, let me stop this thing. Okay, good. Next up, sorry, I had something going on Chrome for a little bit, or in Safari, but we want to pause that for now. Cool. So, next up, after this, so then after this, um, well, I mean, we could both, no, we don't want to both in it. What we'll do is, yeah, alright, yeah, this is cool. So, after this, what I'm gonna want to do is, I don't know, like, so this I plan to input some stuff, but I'm gonna wait till later for this. Okay, you can see on the same line. F-sensors on either side. That match this is gonna like pivot down. Alright, take a look at our example here. So yeah, if you have it fully on the inside, just yeah, I mean, I don't really know. You could do anything. Um, okay, let's get everything spacered out. So like this. what's the distance between you? 0.492. I mean, that's basically point 0.5. You can do this. So just 0.5 in spacer. Also, why is MK coming out? Come on, spacer. Hmm. There we go. Okay. So we want a half inch. This basically means okay, you're getting a half-inch long spacer for a half-inch shaft, which is good. Also, we might want to hide the origin key for now. Actually, no, we don't need to hide it. Yes, we do. No, okay, I'll hide it for now because we're going to be inserting some parts. So, mate, this spacer is called a mate for anyone who just joined. A mate basically fastens one thing to another. And now this can't move. If this moves, then the whole entire thing moves. You see? Cool. So, the next step after this is connect my mouse. Have my mouse. Okay. So, next up, let's see. We got our spacers in. We need to insert the bolts. Um, but I don't know. I'm just thinking. I don't know. Well, we'll do something real quick. Okay. Okay. Next that okay. Cool. So, next up. I guess we can. Okay. I'm gonna say that next up we are going to do some more mating, but with our chefs. Question mark. Okay, this also needs to be fixed. I don't need a bearing for this. I just need. Okay, yeah. So what I'm gonna do for this is I'm just gonna put a little spacer in here. I know our example says that we should put a bearing. I mean, we have the hole there for a reason, I guess. Yeah, I could do a bearing actually. Okay, let's do a bearing. So for our bearing, what we're gonna do is we're gonna take one of these, or I'll teach you guys how to do these. So you do 1.125. Then you just type in bearing. Don't want this one actually. So let's scroll down to actually just type in bearing. Then we can scroll down to 1.125. It should be near the top. Never mind. Don't pick radial, pick flanged. You can pick a radial bearing, but for our CAD, we want a flanged bearing. So this one, under hex OD, 1.125 OD. For anyone who's interested, OD bearing. It's outer diameter, right? So our outer diameter is 1.125 inches. Cool. Okay. So after, let's do this one. Ugh. Sorry guys, I just picked the ads. Too many ads in there. Okay. So now that we have our spacer here, or output bearing. Next up, let us do this. Okay, and then insert. Okay. Now here's the thing. Yeah, and then Okay, so that's the problem. I'm afraid that our little spacer here got caught in the fire. So I'm going to I'll copy it on high, boom. Okay, this thing, you see how I can like just move it all together? So what I'm gonna do, we need another 68 pins, right? Of course you can get okay CAD as always, or you can get back here. So yeah, well, let's now put it here. And next up, we're going to do this. So after I do this, what I'm doing is I'm giving myself some space, and that's for this pulley. Pulley is very important in the power transmission. And I can't really have it falling out of me. Okay, so you see here, it exactly fits, which, I mean, it's nice. And this is a little weird. I don't like this, but anyway, do what you want, right? This thing could be squished a little bit more to the side. So really it's fine, but yes, something to keep in mind. Okay, so next up, you can see here that we have our power from the motor. We have it being driven into some um, gears. They're a tiny little gearbox. Once again, as I said, and then we go to the pulley system. Now, this motor right now is purely just powering our shaft right here. This shaft, eventually with some spacers and with some intake gears, going to help intake it into the robot. Now, this robot kind of has like an intake like going inside, right? So that's what we're gonna do. Now, uh, concerning this, next up we have to power this, right? And yes, this is powered here. Actually, no. Yes, this is already powered. This is fine. Let me put on some more music. Pretty tired tonight. Not gonna lie, guys. Okay. Okay. So next up, after this, um, sorry, just let's switch it back. We will have anything. Oh, okay. Um. Okay. So now we have enough space in here to give a spacer. Uh, let's check the distance on that. It's like and 0.084. So that's like so keep in mind 60 this spacer is like 0.063. I believe that these this when actually CADed right will be 0.063. And so to separate these, I'm just gonna insert a 60 this spacer. So we'll go here and go 60 inch, half inch. So you could use a 3/8 inch hex shaft. We prefer 1/2. It's just I don't know. Both of them are easy to come by. Don't get me wrong. One of them is just I don't know. I prefer half inch. If you're trying to go for 3/8 inch, I guess you could be going for a little bit higher speeds. Those generally do. I mean, think about it, smaller size but faster speed. With your half inch, you go a little bit more time. But I don't know why my mouse stopped working. But yeah, cool. So next up is our space. My mouse just completely is not functioning. So let's see. I'm just gonna see now. If you're liking the stream, guys, feel free to like and subscribe. Yeah. So next up, um, I'm just gonna make this here. Now, in a more professional standard, you would be required to make sure that these fit. I'm gonna guess so. Like you could do here to like here. Okay, so 0.022. If you do 0.084, 0 point, oh no, 1A minus 0 point, was it 22? Then you get 0.066. It's 0.063, so you're only 0.003 inches off from a 16-foot spacer, which is under the tolerance of 0.005 inches as your tolerance. So great. Coming up next, let's take a look back at our example here. Now, this example is from frcdesign.org, and it showcases one for a 2022 ball, which is kind of like round, really big tennis balls, I want to say. They're kind of weird, but yeah, you do what you can with them. But next up, so we have a completely powered transmission over on our right side. Now, moving over to the left side, you can see here that we have a max planetary. So this max planetary, um, what it allows you to do is it's basically kind of like a gearbox in a sense, where you can get your own gear ratio, whereas without having to do a lot of gearbox related stuff, right? So you can see here, we can take a look at it real quick. Um, but yeah, it's just simplified max planetary. It's got two stages. You can see here, one, two. Um, I mean, if you really want to get technical with it, I want to think. I'm trying to think if what's the gear ratio on max planetaries? Yeah, so it can go from 3 to 1 to 125 to 1, just depending on what you have. Pretty sure that. So actually, I don't know. I'll get back to you guys on this, but like, where's my sample? Yeah, this one. I don't. It's hard to say, but yeah, definitely. I'd say this is 60 to 1. I don't know. 60 to 1. I don't know. We'll check in on that later. Okay. Let me just go drink some water real quick. Okay, let's keep moving on. On our right side, we have our max planetary, like I said. Now, we do have this chain here. I know it seems like a belt at first when it's simplified, but if you unsimplify it, I see here that we've got a nice chain. Now, I can move this chain around freely. Um, yeah, so with this, I already pre-belted some of this stuff, but yeah, let's think. If you have any questions, feel free to post them in the chat. I can challenges if you want as well. But I think we're almost done with this part of the assembly. We still have some bearings and bolting to do, but really, I don't think we have much left. We have to set up this, and then we also have to set up a top stuff. On the bottom, we can, like, this example, you can leave it as a shaft. Yeah, so let's focus on that. So you can see here, I have two of the same chains. We've got 125 links. No, 105, sorry. 25 chain. Um, yeah, now with these, it's always important. Sorry, just checking one last thing. Yeah, so with these, it's always important. to make them in the correct way so that they'll be represented sort of like this, right? Because you want them to be able to mate it in this sense. Is this at least semi? Like I feel like this is a fine. Yeah, this is a fine one, and it's a fine angle as well. Really, you want the mate connectors for this one and your output shaft to be the same, because you can see here in our arm assembly that we actually have these. How do they call them? What am I forgetting? Stud gears. That's what they're called. Spur gears. Sorry. So these spur gears, what they're doing is you have a output shaft, right? And then inside here, you could have a hex shaft or you could have a thunder hex shaft. Um, then after that, you have this gear that goes around the chain. So I want to pre-CAD it, right? I want to CAD it in a way so that it's parametrically designed, right? I don't have to move anything when I get to the final assembly where I put all these together. So with that in mind, let um, with this, I'm going to mate, excuse me. Sorry, just gotta place it in YouTube stuff. Okay, so I guess we'll just do this. This is fine. And I'll do it too. You, I guess. That way they're aligned. Let's see what they're in. Now the only thing is on this axis, this way. This axis, we don't really like that. So I'm going to just shift it over a little bit. No, it's not really like it. Yeah, okay. So why is it that's weird? Let me check. Cool. And spacer. Okay, there we go. Much better. Okay. I do. Yeah, that's getting rid of. Okay. So next up, see how this is all mated together? I click on my left plane. This is all mated. There are no extra mates outside, right? They're all in that one center position. And the good thing about that is now all I need to worry about is this axis, my x-axis. No, z, sorry. So speaking of my z-axis, cool. Okay, so I don't like that. Hold on, let me try again. All right. Sorry guys, one last time. We're gonna do this, and then this, and then cool. All right, now my offset. Let's go. Okay, this now 705. Okay, then we can just manually. Sorry, okay, 7 1605. 16. Yeah, this looks fun. Okay, is it happy on both sides? Is the question. Yeah, actually, that's really happy. Cool. So you can see here, that's the good thing about parametric design is I designed these in the part studio so that they're aligned. And then I don't really have to worry about that when I get to the real part. Well, it's taking a long time. So, yeah. We have our chains here. Now, they'll connect with here. Um, yeah. So next up, okay. Now the thing is, you see here that my push ups doesn't really fit all the way into the end here. The other thing is, I don't know. Like you kind of have to worry about this. The the example doesn't decide to worry about with this. They spilled both of them. It's fine. I don't really have a problem with it. I think it's fine. Yeah, especially if you put a bolt on the end. Yeah, that's fine. Also, typically, send the where is it? Yeah, they probably didn't show it in the CAD, but you fasten a bolt from the other side of this explanatory into the shaft, which is what is going to let you eventually keep the shaft from moving. I don't know if they CADed that. Like that would be a pretty complex thing, but I'm not. Um, yeah, let's see. All right, let's think. Yeah, hold on. I just want to isolate something. So yeah, so you see here we have this. Now if I isolate this to variable, but sometimes implementally. Maybe not for this one, I don't know. But yeah. Okay, let's put back all of our things. There we go, good. Should wait. Okay. So what's next, you might ask? Well, we gotta do it to the other side. Now this side is going to be much easier, trust me. All we're gonna do is just do this one. And I guess we did two. They're all the same center. Okay. Anyway, like 0.15, I guess. Yeah, 175. 1.5 and 1.75. What's that? 1.625. I mean, it's acceptable. Yeah, it's acceptable. I mean, there's like the I get 0.456 by the like half inch. 46 doesn't make any sense. Um, okay, 0.003 versus 0.01. So that's 0.01 inch. So 0.05 inch difference in there. That's not really going to affect your normal run. Okay, this is our problem though. Is we have this. So what we need to do is fasten you to like you, I guess. Alright, so now you'll see that it's actually the only thing is it doesn't like it when I'm way too loose. So what you're gonna have to do, I guess, is just manually, right? Like adjust it. I think it's rotating on X. Okay, no, and let's see. I'm not gonna yeah, that's fine. Okay, cool. So, no, I don't care about that. Negative 15. Did we do for the last one, like -8 or something? -7.75. Yeah, -7. Yeah, -7. Okay, this is like an acceptable amount of distance. So that one worked out. That one didn't. I moved around that other one a little bit, but I mean, it's see like that. That's the difference between them. That's not too terrible, but just keep in mind in your life sometimes you want to align them a tiny bit better. Let's see where else. Okay, like, yeah, I mean, there's small difference in between those. Okay, so you might ask, what's next? Well, we have our arm catted out, and we have our static assembly, but the only thing is, um, I would also love for us to, I mean, like, just, I don't know, like, we'll cat in the bolts for sure, and then uh, before we cat in the bolts, we'll just do this. We're going to have just a static, not a static, a rolling dead axle right here. No, we're just gonna have a rolling shaft. I don't know, stuff. But then after this, we're going to have some rollers here. Now the thing is with our rollers, really depends on our other CAD. See, in our arm assembly, I'd like this, and alright, if we take a look at our part studio, this is a tiny bit bigger than this. I want to make sure it goes all the way. So, what we'll do is we shall import you and then the two of you so that I know what measurements to work off of. Let's do that. So I'm gonna get my arm roller. Well, that's what I called it, arm roller, and then my two arm shaft plates. Where are you instancing? But that is the worst place to instance. Why would they ever place it down? Okay. Like I said, what this be? Still no. Okay. Huh? I don't know. Okay, those were so. I mean, yeah. Okay. Next up is we're going to watch our leg belts. Let's see here. Arm roller and then arm shaft plates. Now my question is, where do you guys insert? Yeah, actually, it doesn't really matter. Sure. And then I'll just see what the distance is between these. Like, you, the distance is 12.5 inches. Okay, so let's do the math here. Your distance is 12.5. And the distance between you and you, 19.4 inches. I'm pretty sure this is just 20 inches distance. This is 19 point, yeah, this is it, yeah. So this is 20 inches apart, so 12.5. Um, so that's 7.5 inches for each side, I guess. So then we'll do 7 inches for each side between these plates, and then run some arm rollers on the yeah, on there, and then that's gonna make sure that the coral. This is called a coral, by the way. If anyone's interested, is gonna make sure that that's on. Okay, cool. So let's do that. We have you and center B. You can hold shift, by the way, if you want to do that. And then yeah. And first that, okay, so with this, I'm gonna make an offset of 7 inches in the other direction. Um, yeah, this is fine. Right, did I do the math right? No, 7.5 inches, and then, oh no, hold on, this is 6.25, so then I'll do 6. No, 3. 2.75, so negative 2.5. Negative 4. Yeah, I'll stick with negative 4. Maybe yeah, I think that's where we're gonna have to replace. I will then proceed to duplicate this and place one on the other side just to get a little bit of good peripherals here. And some water. Wow, still no one. That's crazy. Next up, we are going to do this. This is the bound. No, we'll just do it from there. This is fine. Guys, this, yeah, the center of this is fine. This is fine. Um, oh yeah, that's fine. Sorry to flip. Make an offset of about what I surveil? 3, no, 4 inches. In the opposite direction. Okay, so now we the voice space out. 4 inches, 4 inches. Yeah, I think that's about right. Okay, good. Um, cool. So next up on our intake is we're going to want to add some other things. This. Also, it's like clear. Yeah, hold on. We should look a tiny bit better. A little bit. It's not better. I think I made it good. Cleaner. No, I don't. Okay. Let me try one last thing. Still not taking. Okay. Going? Oh yeah, there we go. Okay, perfect. I think I should be able to see a little bit better. Okay. Yeah. Next up, I'm just going to do this. With this, I do. That's fun. Okay. I think we can put a 1 inch between these guys. Is that a 1 inch? What I did here. 1 inch. Yeah, yeah. 1 inch. Okay. Yeah. Um. This is here. Wow. My battery is getting drained right now, guys. Okay. One is. What's this one? Yeah. Uh, was it outside the yeah, yeah, outside the yes, this is a rare deal. entries. Is there yeah, like flange, like that one flange at the top. Yeah. So cool. Next up, we have our spacer. So I don't need to CAD anymore. Cool. Then after this, I will insert you right there. Perfect. Okay. And now I can proceed to just generate them. Now this is 1.25 thick. So what that means is I'm going to need some little something extra. Um, we will replicate you. Not replicate. I'm really tired, guys. Direction will be towards you. Distance between them 1.5. Alright, now I think 7, like 10, 9. Okay, here's our problem is we have these. This is great. This doesn't infect the motor, which is awesome. The only thing is I'm worried that when we actually intake, because something's gonna go. I don't know. We'll do fine for now. This, we'll just have a little extra space. Ah, that is weird. Alright, here's what we'll do. Pretty sure it's a half inch between you and you. It's the center distance. This is not center and distance. That's what we put the center distance. Okay, good. Zero point 0.5. So reason why whoa. The reason why we want this is because okay, zero point 0.5. Now if I move each of them 2.25 inches closer to each other, this should work. Yeah. So let's do that. Um if I go to my fasteners, which are negative 4.25, and also I will go to 51 and do negative 4.25. And divide by doesn't make sense. Okay, yeah, this seems good. Now all I need to do is just add a bunch of spacers. Then I think actually we should be like semi done. Really all we need left after this will be just some uh, tidying, like bolts. Did I ever insert holes for this too? I didn't. I need to insert some access holes for those eventually. Um, I might need later, guys. Then after this, if it's true for now, cool. I don't need you anymore. These guys. Okay, cool. I can just move them. So, I don't know. Yeah, it's like 8:47, man. Yeah. So next up, what's this? What did I say? 4.25. Yeah. So what I'll do is I'll input a spacer, but I want to configure Songgle so hard, guys. Okay. Spacer is stack, yes, and length should be 4.25 inches. I don't want to use too much spacers. 1 inch. Yeah, we should only do this. There's actually a really cool feature script where it can automatically do the spacer for you. You see, I have four of them, and then I have one quarter inch, which is definitely cool. So, and they're all fastened together, which is the best part. Saves you a lot of time. So I do this, and then either I can duplicate it, which I mean I probably will. Why did you have this? Okay, okay, paste this. And just for cases of symmetry for a lot of people out there, I would, oh my goodness, I will have to go up to here and we'll use, no, symmetry, guys, symmetry. I can see this. Alright, cool. Oh, I forgot. Shoot. This doesn't work. Because this is the difference space. This is like 0.5 plus 16th inch. Hold on. What's the difference? Distance between you and you. Of course you don't agree. You, you, inch, CAD. Oh my goodness. CAD back in. Yeah, okay. 2.687. Honestly, not the best. Okay. I did the math wrong somewhere, but we'll do. Was it 3.687? And this one, I'm not gonna allow 2 inch or that's it. I mean, everything else is good. It does that for me, which is really nice. Especially if you're starting your own team, it's really nice to just have something to do stuff for you, like our team, over Investor. Okay, where is our thing? Waiting on delivery. This really is kind of hard to. Okay. Next up. Yeah. So, I know interesting. All right. Next up, I'll insert you as an eighth inch. All right. So can't be missed symmetrical. I'm sorry, guys. Oh, that's horrible. I want this one. Okay, this would be a little better. Yeah, if I saw you. All right, great. Why? That is so sad. Okay, honestly, what's the distance between you two? Why didn't they include this? That's weird. Hold on. Shouldn't it have 16 inch? That's weird. Okay, very nice. I don't know why it did do that, but what else, guys? What else? We'll do it ourselves. I'm gonna do everything wrong today. Okay. What is this? This telephone. I got going. I guess. Now that shit literally produced. Like, yeah, literally zero. Like, very little. Max point oh oh one, which is great. 0.6 Yeah. Yeah. Okay. Cool. So now we got a little intake going. Um, I yeah. Wait, what's wrong? Oh, you don't have to make this here. Why is there 30 seconds? No, that's something good. Right, internet, whatever. I don't care. I care, but it's fine. How do okay, that's right. I forgot. Okay, cool. Okay, so you can see full that qualifies. Yes, it's correct going in. So that should be able to. Alright, so you can see here, not barely fits. Like typically want a little bit more leniency just because of how the coral at times is a little bit tricky. Um, See, the thing is, when you have a hard substance, right, like a coral, the coral is a PVC pipe. I can show you coral first. So yeah, you can see here like this, right? So this is what it looks like, right? This is a PVC pipe. So for PVC pipes, they're generally pretty like tough, right? And for tough game pieces, malleable. So malleable grippers, malleable, I don't know, flywheels, something like but the thing is, for softer game pieces, you want harder wheels, right? You want like harder, I don't know, like intake rollers, right? So that's the question here. It's like, what kind of intake rollers and arms you want? Now, the thing is, for the coil, we're just using these spinning things. These things really don't gain much friction on the coil. The reason why we're doing these rollers, and you can CAD these yourselves, by the way, is we're doing it so that they can just slide off the coral and go into it, right? So the coral will just slide through and into the box. That's why I also have these here, because you see this thing, it will drop down and it will just suck the coral right up, right? Using our bumper, we're also able to kind of like rip it and make it go on. Now the thing is, the only problem with this is our shaft space. It doesn't really follow the rule. Our shaft here is very hard, and when it rotates, it's gonna help bring the coil in, but it'll be a little bit tougher. I should have probably put like some sort of malleable roller on, sort of like this one. But I mean, we'll see. We'll have to test it out in real life eventually. Yeah. So after this, all is bolts. Yeah, all we have left is bolts. One quick thing is we have made this 3D printed part. Let me just you can see here, nice little part. Um, yeah, I mean, it's just nice to have. Yeah. Let me do a section view. Like, Yeah, it should be. Yeah, perfect. Cool. All right, after this, then we're gonna do some early bro. Almost there, guys. All right, couple things are Fulton Washer. I said to myself I'd get this intake done by the end of the week, and we're almost there, to be honest. It's Thursday, and we're kind of almost done with the subsystem. There's still a problem with like feeding it into the well. A couple more problems with that, but overall, this is really coming together well. So, all right, moving on. We have our bolts and a washer. Actually, I should just, yeah, bolt washer. If I search up, yeah, it'll still show up like this. So you can just search up bolt washer. Fortunately, I think they only have a half inch 232. No, they have others. Sorry. Let me, anyway, bear with me. 2020. Okay, cool. In case anyone's wondering, what the Big 1032 is the diameter from say here to here is 10 millimeters, and then 32 is how many rings you have per inch, right? So I can actually render this. Uh, I can't render in high texture mode. I don't have that yet, um, but it'll help us a lot. And the reason we're using a washer is because for a lot of parts that are polycarbonate or even aluminum, and just stuff in general, you want to take out the load, right? You want to help distribute that load so that it's not all concentrated right where the bolt is fastened. If you concentrate it all right there, what it's going to do is it's going to eventually make it kind of like crush in on itself. So yeah, that's something to keep in mind. Okay, so let's keep going here. I should insert this here. Oh, now in reality, I should be replicating this so that I could go on all of these different shafts. So let's do that right now. Switch to the example real quick. Yeah, we have a bunch of this. This side. Okay, good. You can see here that I have my bolted washers, and then I also have bolts right here, which is awesome. Um, and let's see, where else do we have bolts? We have bolts and nuts going here. Then, yeah, we're almost there, guys. I think it's 1 inch. Never mind. They are like 1.5. 1.75. Okay, yeah. I'm afraid I don't think I put the number in the right place. Actually, this one I did. Did I do it for this one? Afraid I didn't. Hold on, let's check here real quick. Isolate. Okay. Yeah, I did it. Shoot. Uh, okay. We'll just rotate them. I don't. Oh, I don't know if the. Okay. Let's see here. Where's the one between? Oh, almost found it. Is it this one? Okay, let's check here real quick. So now if I rotate the motor, oh no, this is between this thing and this. What's this going to be to? No, this- wow, it's not minus. Oh, it's this one. Okay, 21. Cool. So now I can offset it. And actually, I rotate 180. This is not going to work. But yeah, you can see here that like we can rotate it in all different sorts of degrees. And it'll rotate. Cool. Now I want to see if I rotate about like y equals 75. Feels like up like that, right? But you want it down. And then we want it rotated by z a little bit. How much we want to rotate it really depends. I want it to match up with these rules, which is like impossible. Um, Let me try to fix it here. So, okay, this is possible. If I rotate it to degrees, it's gonna be 8 seconds. Like, then we can just check over and over. Okay, let's check. Isolate. Okay, here we go. Um, what are you? These are the no, these are the ones. Oh no, these are okay. If I do this, I don't. Yeah, this is good. Good. Okay, couple more degrees. We're just into 21. Like negative 12. Oh, close. Alright, I'd say negative 13 is acceptable. Could we have gone for negative 12.5? Yes. In fact, if we go for that, I mean, that's like almost perfect. I like negative 13 now. Like, it's like technically 12.75 is the optimal. Yeah, makes sense. Cool. Alright, then we should insert 1 point. What was this? Yes. Why do I insert one random? Oh, yeah, yeah, yeah. Okay, okay. Focus. So let's do. Actually, we're gonna insert some standard content. Stock ahead is good. We want 1.75. Oh, come on. 1.5. Also, one there, I don't know why, but like they have 1.375. And the 1.875, like 875 should be in between 0.75 and 2. Okay, but my case rests. We'll do you. We'll do you. Nope. Oh, there we go. Cool. And yes, this should be good. Here's the thing: is if we isolate this, doesn't it fit inside? Like, yeah, yeah, that's okay. Um, Now we also need to insert them to here. Here's the question. I think we insert, yeah, in here. Now this is between you and like the middle of here. So this is between you and you. I guess I don't know. Oh, I can this is it. Okay, so two. Okay, so we'll do 1.75 actually. Okay, one. Insert. Yeah, 1.75. We're just gonna insert them again, to be honest. I mean, what's the insert. Um, I actually, yeah, I hate it. So I just got one. Okay. Next up. Well, actually, how far did you do this go? And yeah, this looks fine. Yeah, that's fine. Okay. Then after this, we need the bolts running through here. Actually, I think these are 1.75 as well. Let me just stop looking out of that. Because, yeah, these are totally. And I also need to hide that. See, normally you would have one, but I did the chain thing wrong. Uh, yeah. Okay, next up. Let's see what I need to hide. Cool. Um, yeah. So let's keep going here. Yeah. Oh, it is tough to say, guys. Okay, next up. Yeah, insert. Okay, then I'll insert. Yeah, you see, even though we're missing one right here, this is still better than nothing, to be honest. Then you and you as well, just for a little bit of extra stability. Yeah, I guess as well. Actually, these bolts will run through. Yeah, it's fine. And then you and you. You should have six by the end. Actually, can't. Let's try to you. Just gonna let me. Ah, that's awesome. I'm gonna start one there. Um, oh shoot. Yeah. Okay. Cool. Is that all for now? Yeah. It's good. Good. All right. It's coming along. Next up, do bolt-in washer, insert access holes, and do the small bolts. So you have your replicate here, guys. Replicate is important. All right. So this digital matches. Good. You gotta work. No, you don't. Of course you're not. Why do you never want to work on? What did I fasten you to? And I just had, yeah. Uh, stupid. Yeah, let me try to do this and then we can see. But it's, wait, you know what we can do is, I can trust on this. I can go to replicate. this. Yeah. Actually, no, no. Yeah, you should. Yes. Nice. Cool. So now we're just gonna do that 50 million times. Okay. Yeah, that should work. And really that's that. This really takes a long time. Doesn't like this. Almost all day. That's my life now. Going through this. Sure, just as supportive. Feel free to go down to that GoFundMe. We really appreciate it. Stuff out here. Um, yeah, but those here just watching, that's even better. We always love your support, and just wanted to let you guys know that. Thank you for watching. Uh, okay, so we'll do this then. I know there's other games out there that people would love to watch, but thank you guys for watching. Genuinely. I know this one might suck, so but honestly, I love that game. No shade to it, but um, yeah, it's just it's tough finding people. So we literally just hear names right now, but because minutes, hopefully share this is fun. Okay, uh, next up, all right, next up, what really got into is we got to set up this other stuff. So, let me think. I don't know. It's like, all right, now, Chaco. Oh, so close, guys, so close. Going. Shoot, this doesn't go all the way through. Oh, I did those two wrong. And subsequently these two. Okay, that's fine actually. That's not too bad. So we'll fix those, add the nuts, and then access holes and swivel. Okay, yeah. This is doable before 10, I'd say. In case anyone was wondering. And then we can work on some frog. Yeah, I'd say this is like images. Yeah, okay. So if you do uh 2.5, 2.25, I think should be fine. Such a headache with this thing. Oh, all right. 2.25. Yeah, there are them. Like it's such a headache or something. This is nice. Yeah, this is a good plan, but fortunately, I don't want to do all of that. I just need to do these villages. Yeah, cool. So now I have an insert nut. Yeah, that's fine. Uh, that's oh, wow, watch it really doesn't like it. Next up. Well, All right. So then, after this, you might be asking, what do you want to do next? Well, um, next up, we are going to want to start modeling some of the things. Um, yeah, we may take a quick break. Here we go. All right. This is showing right now. Is that showing my mic? I don't know. What's the name of this screen? Uh, all right. Let's. All right. Almost there. Almost there. Next up, got some more bolts. I think how many bolts? You got these ones. What do we got? We got these ones here, and this is here, and then the axis. Okay. Just half inches? No, definitely half inches for sure. Yeah, half inch should be fine. Insert, and then go to bolts. Okay. Yeah, sure. I'm sure. Yeah, those are good. Yep. If we go like cross way. Yeah. Good. Okay. Next up on our agenda, we discussed in this one. These are also just, yeah, everything is just average. Okay. Yeah, that's good. And then more half inches. Actually, yeah, it should be half inch. Everything is just half inch. Okay, yeah, that's good. Cool. So let's do that. Let's do it. One, two, three, five, six. One, two, six. And answer one at the top. Hold on. What should we do? We should do one at the top. One here, one, two, one, two. One, two. Yeah, that's fine. Yeah. Okay, so we have to just slow this down. One, two down, two down, two down. And this one. Yeah, this one. Okay, yeah. Uh, let's see what else we can. Yeah, it's just the access tools, and I forgot about these. Um, it's actually a question. I don't know about this. Why do they not have this? Do it this way. Yeah, yeah, that should be cool. And then it's like 1.875. Yeah, 1.75. Yeah, we should be doing this at 0.75. Yeah, okay. Um, why is this? Okay, what am I doing? This is, yeah, this is really not small. That's fine. Yeah, really thanks. Let's try it. Alright, we'll be getting a little bit more commentary. Okay, so next up, we're just gonna insert the bolts here. You could do 1, 2, 3 for a little bit more factors. And I don't know, we might have a little backlash. So we're gonna do. Oh, it's with the nuts first. Do it backwards this time. 1, 2, 3. And then our other side, of course. 1, 2, 3. 5 axis. I answered that. Yeah. Next, I'm going to return space symbols. Now this should be 1.75. There, 1, 2, 3. Come on. 3. Ah, nope. 1, 2, 3. Wow, I'm really bad at this one. But now if I change without all the keys instead. Delete this. Next third. Oh yeah, that's fun. Cool. Okay. What is next, everyone? Next, yeah. All right, let's do a quick check before we go on to the question. Mhm. Yeah. These are called um, shit. What? How did I forget? Not strip, is it? Violence? Yeah, okay. Yeah, this stuff. Cool. All right, what's next? Okay, so next up, let's see if these will be able to spin eventually. I I moved this. Yeah, I forget. Okay, good, good. All right, this seems to be going well. Um, yeah, okay. Yeah, I'm just gonna go back to this. Oh, I forgot. No, no, wait, no. So I'm going to add. Okay, just gonna make one quick sketch here. Two. uh, I'm not being smart 19%. We spent almost all of our. Okay, interesting. Alright, I'm just gonna also. Yes, this one. Alright, next up. Okay, let's do this. Wow, this is annoying. Okay, you know, look, I'll just do this. Yes. So 936, we can make it. And with the distance between like 0.15, we can fit a screwdriver in there. Cool. And then just gotta reflect it. There we go. Of the face. That's this one. No merge of select. Yeah, well, should work. Move a little bit. Alright, so you figure out this is between you, like almost standard distance, but actual is 0.154. That's a little low, but we can deal with that. Okay, yeah. Why the heck does it not copy of it? Whether or not it's then I asked you to everything. And now you feel like, oh, this is annoying. Okay, so you can see what I forgot to do here, guys. I forgot to merge. It's let's see. No, it should work. There we go. And I just gonna add these two superstructure too. Yeah, cool. Seems good. Cool. So, what do we do next? You might ask. Well, at the moment, I'm just gonna do one final check. Yeah, good. Okay. After this, we're all done. We finally did it. Just took me about 2 minutes to do. A little longer than I expected, but that is life when you do CAD. What's the no point? Yeah, it's fine. Let's put 0.02. One. It's like 2,000. 1,500. Okay. Um, 176. Okay. 88 out of 250 with 425. With 425 is still 7 million. Next step is combine these two together actually. It's the funnest part. That's why you can just like this. There's it. It's just like this. And one more assembly, which is a assembly. Oh, now I'm gonna import two things. I'm going to insert my parts. I'm going to insert my own assembly. Cool. And I just don't want this. I don't need to. Cool. So now in take assembly, you should just automatically, yeah, okay, you're not liking something. I know you don't like it. What's wrong with this? We're missing selections. You know, again, it's pivots. Arm assembly is fine actually. Yeah, you're fine. Sure. It's not a show you want to do. And we've done it. One thing we did wrong. Okay, we need to get that fixed ASAP to get this fixed. Okay, this one, yeah, this one. And pressing you. And then copy this to whatever this thing is. Yeah, let's show it. And then we shall show it. Okay, yeah, 21 to move. Good. Plus two. is it? Yeah. Mm, what is it? I don't know. That's right. Sorry. Yeah, they really put it. Yeah, yeah, good. Yeah, if I go into something, all the parts should be able to do. Just done. Right. Okay, perfect. Now, I need to fasten as I run into it. Yes, certainly. Is a tough part. Hmm. Yes, some stuff.